All right, let's do some trig sub. Let's first complete the square in the denominator. And when we complete the square there, our goal is to write this expression as a sum or difference of squares. And ideally, we write it as a sum or difference of squares with a 1 in it. And the reason I do that is that there is less memorization in the long run with all of these trig subs and trigonometric integrals, inverse trigonometric integrals. So we're going to write this as x minus 2 quantity squared minus 4. And I will then factor a 4 out of the denominator. It's going to come through the root as a 2 in the denominator. The numerator is just sticking around waiting to be changed momentarily. When we factor out this 4, we're going to rewrite this first term inside the square root like that, so that we have a difference of squares with a 1. And that sets us up for trig substitution really nicely. So our trig substitution, we are going to let x minus 2 divided by 2 be secant of theta. If it makes it easier for you to find your derivative statement by isolating the numerator there, totally fine. Not necessary, but it will work. And this tells us that dx is going to be equal to 2 secant theta tangent theta d theta. And if I poke my head into the numerator here, I notice that I have an x squared. So what is going to be useful will be this. It's going to be useful to solve this statement here for x so that we can do our substitution cleanly. So let's get back to our integral and do our substitution. So in the numerator, we have x squared. We've got to FOIL that, so that's going to be 4 secant squared of theta plus 8 secant of theta plus 4 plus 3x. So 3 times this. That's 6 secant of theta plus 6 plus 4. All of that is going to be multiplied by dx. dx is 2 secant theta tangent theta d theta. In the denominator, we have the square root of secant squared minus 1. Secant squared minus 1 is tangent squared. So that is what we end up with after all that substitution. Let's do a little simplification here. We know that the square root of tangent squared is tangent. So that whole piece is going to cancel with that in the numerator. So those will both go away. And we will be left with, I guess we could, let's not do it yet. So we'll be left with 1/2 integral. We have to distribute this 2 secant of theta. And actually, let's go ahead and do what I was going to do. Let's cancel this 2. This is being multiplied. So that 2 and that 2 can both go away right there. So let's rewrite the front here with no 1/2. Don't need a 1/2. All right. So now we're going to distribute this secant right here over to this quantity and not making mistakes. So 4 secant cubed of theta plus 8 secant squared of theta plus 4, let's get all our constants together. We have 10 plus 4, that's 14 times secant of theta plus 6 secant squared of theta d theta. We have one more step where we can combine like terms. If we wanted to, we could factor out a 2. Doesn't look like that's going to help us tremendously at this moment, so I'm just going to leave it. All right. We are now at this step. And this is fairly easily integrable. We've already dealt with secant cubes in the past. And so we know that integral of secant cubed is done by completing the square. We know it's kind of messy looking. We'll write that down in a minute. We know how to integrate secant squared. That's tangent. And we know how to integrate secant. That's natural log of sec plus tan. So let's go ahead and plow through this. This is going to be 4. And then the integral of secant cubed is going to be 1/2 secant times tangent plus 1/2 natural log of secant plus tangent Okay. Integral of secant squared is tangent plus 14. The integral of secant is natural log of secant plus tangent. Let me see if I can move this over a smidge so I can have it all in one line. Whoops. Okay. Natural log secant theta plus tangent theta. And running out of space. We'll just do this. Plus c. Okay. Let's distribute the 4 and go from there. So we're going to have 2 secant tangent right here. Plus 2 natural log secant plus tangent. But over here we have a natural log of secant plus tangent multiplied by 14. So that's going to end up being 16 natural log absolute secant plus tangent plus 14 tangent theta plus an integration constant. All right, now we're ready for our triangle. Let's go back up to our let statement for a minute and figure out what our triangle should be. So we have that secant of theta is x minus 2 over 2. Secant of theta is x minus 2 over 2. That triangle will show the relationship between theta and x. That makes this side the square root of x minus 2 squared minus 4. Now we can go ahead and do our conversion back to x's. So we have 2 multiplied by the secant of theta multiplied by the tangent of theta plus 16 natural log absolute value of secant theta plus tangent theta plus 14 times tangent of theta plus an integration constant. Let's go ahead and simplify. So we will have x minus 2 times the square root of, we can square this out and simplify what's in here a little bit. We'll end up with x squared minus 4x plus 4 minus 4, so those cancel, and this is all divided by 2. And then here, we're going to use a log trick. This denominator is the same, so we can separate this into log of the numerator minus log of the denominator. Log of the denominator is a constant, and it can get absorbed into the c over here. So we're going to have plus 16 natural log absolute value x minus 2 plus square root x squared minus 4x if we simplify what's in the square root. And then over here we get 7 times the square root of x squared minus 4x. And then we have our integration constant. Boom.